Okay, today we will be learning about Newton's second and third laws. Remember, if the notes are in a T-note format, you take them. Sometimes I will have a prompt to let you know whether or not we will be taking notes. So make sure that you're pausing the video where you need to and listen to the entire video for understanding. Let's begin. So go ahead and draw this in your notebook. You want to draw the free body diagram of a book that is sitting on a table. Remember to identify the forces and their magnitude. Pause the video and start it back up when you're ready. All right, so when we're drawing a free body diagram, remember we have to identify what the forces are and to make sure that the magnitude or the lengths of the arrows are also correct. So we have gravity that is pulling down on the book in this direction, downwards, and then we also have the table pushing the book up. And so that is the normal force. So what you should have for a free body diagram is something that looks like this. Notice that the arrows are exactly the same because the object is just sitting there. Now you don't have to draw this, but notice here that the arrows have changed. Here we have the normal force greater than that of gravity versus in the second scenario we have the normal force smaller than that of the gravity. In both of these situations, what would happen if the forces were imbalanced? So with this one here, if gravity is less than the normal force, then we know that the book would then be flying upwards or being pushed upwards. And in the second scenario, we know that because the arrow for the normal force is less than that of gravity, that means the book would be moving in the downwards direction. Go ahead and draw this free body diagram in your notebook of a spring that is being pushed down upon by a person's hand. If you were to draw the free body diagram, you would see that again, it would be in equal and opposite directions for the spring force as well as the applied force. Now, if we had this scenario, these two scenarios, what would happen if the forces were imbalanced? Over here we have the spring force greater than that of the applied force, so then that would mean that the spring would be winning. It would be pushing upwards and moving upwards. In this direction, you can see that the applied force is greater than that of the spring force, so therefore the spring would decrease in size and volume. Here we have a truck and a dog. If this truck hits this dog with a force of 20,000 newtons, with what force does the dog hit the truck? Now this might seem like a strange scenario, but if you thought about it, the dog would actually hit the truck back with the same amount, 20,000 newtons. And this is because the truck exerts a certain force on the dog, which is the object or body B, and therefore the dog will exert the equal but opposite force on body A, which is the truck. This is the epitome of Newton's third law. So what is the law that we're trying to show here? The book sitting on a table, equal amounts between normal force and gravity, and a spring being pushed on downwards by a hand, equal and opposite forces. This is always true. Right now, what we have just talked about is Newton's third law, and this is also known as the action-reaction law. For every action, there is an equal and opposite reaction. For every force, there is an equal and opposite force. And you can see this with this one example here, and go ahead and draw this little diagram here of the book. The book is pushing on the table in the downwards motion with the same amount of force that the table is pushing up on the book. Now, you don't need to draw this, but take a look at these three scenarios. Here we have a golf ball on a tee, and we have a golf club. And notice that in scenario 1, the golf club is pulled back at a certain angle and released to hit the golf ball. In scenario 2, we have the golf club being pulled back even further, so a greater angle away from the ball and then released to hit the ball. And in the third scenario, the golf club is pulled back at the largest angle, the furthest away from the ball, before it is released. So the question is, what is constant in all three scenarios, and what is changing? If you said the mass of the ball or the size of the ball, that is correct. And what is changing is the force that is being applied by the golf club. And how we are changing the force is by pulling the golf club further away so that when it releases and drops down, it gains more and more momentum. So the amount of force that the ball is being hit increases. Here we have the lowest amount of force being applied to the ball. Here is a medium amount of force, and this is the greatest amount of force. Now predict what will happen to the ball's acceleration in each of these scenarios. So here we have the lowest amount of force. As we increase the amount of force that is applied to the object, when that object's mass is the same in all three scenarios, what you will notice to the acceleration as your force increases is that the acceleration will also increase. Here is another scenario, and please don't think that I'm condoning this, and you should never do something as cruel as this, but we are using this as an example. So here we have three different scenarios, all involving a kid and a dog. Can you tell me what is constant in each scenario and what is changing? From looking at this, you can see that the constant variable in each scenario is the child. So the force that is applied is exactly the same. His leg is pulled back at the same angle, and he will kick the object with the same amount of force. So the amount of force is the same. The thing that is changing is the size of the dog, or what we call the mass of the dog. You can also say the weight of the dog. Now, can you predict what will happen to the dog's acceleration in each of these three scenarios? If the force applied is exactly the same, then what you will notice is that as the mass of the object that is being moved increases, while the force applied to that object is the same, the acceleration will decrease. So what are the two factors that we have discussed that can affect acceleration of an object? It is the mass and the force. So if we change the mass and the force, we can change the acceleration of an object. We know that the second law states that the acceleration of an object is directly related to the force that is applied to it and indirectly related to the mass of an object. And this is mathematically displayed in this equation. F equals ma, where F is force, measured in newtons, m is mass, and it is measured in kilograms, and a is acceleration, measured in meters per second squared. Now, what this equation tells us is that Newton's second law states that if we change any of these variables, it will affect the acceleration. It takes 1 Newton of force to accelerate an object that weighs 1 kilogram and moving that 1 meter per second every single second. So it is experiencing an acceleration. So if something has 1 Newton of force, we know that we can accelerate 1 kilogram object 1 meter per second every second. Notice here that I've placed 3 different equations. Here we have the original equation of F equals ma, which is the same one right here. But notice that I move the variables around, so sometimes you're going to be asked to solve for the mass. And if you do that, then this is the equation to solve for mass using the same original equation above. If we solve for mass, we have m equals F divided by a. And if we solve for acceleration of an object, then that is a equals F divided by m. All these 3 equations use the same 3 variables. It just depends on which variable you are trying to solve for, which will determine which equation you use. You will be asked to know how to use all 3. What is the relationship between force and acceleration? If we were to increase force while mass is constant, the acceleration will also increase. This is what we call a direct relationship. When your 2 variables are on different sides here, if you were to increase the force, it directly increases the acceleration. Vice versa, if I were to decrease the force, I would decrease the acceleration. So for example, remember when we were applying different amounts of force to an object that had the same mass? This is that kind of example where you see that direct correlation, where when you increase the amount of force applied to a same object of similar mass, then the acceleration will increase. All right, so what is the relationship between mass and acceleration? If mass increases and force is constant, then acceleration will be indirectly affected. And so this indirect relationship shows that when you increase the mass and apply the same amount of force, the acceleration will decrease. Vice versa, if the mass decreases, then the acceleration will increase. For example, when we had that kid applying the same force on dogs of different weights or different masses. Here is a diagram showing that some force of the same magnitude is being applied to two different objects. This looks like a bag that's in the air, and this is a car. Using your knowledge about force equaling mass times acceleration, figure out what the difference is between these two objects. And can you predict what will happen to the acceleration of both the bag and the car? So, knowing that the difference between these two objects is its mass, as I decrease the amount of mass, yet apply the same amount of force, I know that this object's acceleration is going to be greater than that of the car. So we have a small mass equaling a large acceleration, and we have a large mass experiencing a smaller acceleration. I would like for you to complete the review worksheet, which is located in Google Classroom, as well as should have been handed to you physically in class. Thank you for watching and have a great day.